Hey, welcome. Our whole world, especially our digital lives, is just this giant, complex web of connections. From our friends on social media to the shows we binge watch, it's all connected. But have you ever wondered how computers actually make sense of all that? Well, today, we're going to break down the super powerful tech that's learning to see the hidden patterns in our connected world. Let's jump in.
Just take a look at this. This is a map of all the character relationships in Game of Thrones. And yeah, at first glance, it just looks like a total mess, right? A tangled web. But what if a computer could look at this and instantly understand who the heroes are, who the villains are, or even predict who's about to betray who? How in the world would a machine even start to figure that out?
Well, that brings us to the first really big idea. See, to an AI, this isn't a mess at all. It's something called a graph. And understanding what a graph is, well, that's the key to unlocking all the secrets hidden inside these connections.
Now, graph might sound a little technical, but the concept itself is actually beautiful in its simplicity. All a graph does is break down a network into two super basic parts. You've got the individual things in the network, and then you've got the lines that connect them. Seriously, that's it. Things and the links between those things.
Okay, to make this really stick, let's bring in the Peanuts gang. On the left, we have our things, right? The characters themselves, like good old Charlie Brown and Snoopy. And on the right, we have a bunch of information about them. This is literally everything we need to build our very own graph.
All right, first up, let's get our terms straight. Each one of those things in a network is called a node. So in our example, Marcy is a node. Schroeder is a node. If you're thinking about a social network, your profile page is a node. On Amazon, a product is a node. It's the most basic building block. Simple enough, right?
Next up, we've got the link. Sometimes people call it an edge. This is just the line that connects two of our nodes. And that line represents some kind of relationship. So the friendship between Charlie Brown and Snoopy. Yep, that's a link. It's literally the connection part of this whole connected web.
And finally, we have attributes. These are all the specific details we know about each node. Remember that table of info on the Peanuts characters? The fact that Linus's major is philosophy, or that Marcy's is psychology? Those are attributes. And as you're about to see, these details are absolutely crucial for making really smart predictions.
Okay, so now we know what a graph is. We've got our nodes, links, and attributes. But how do we actually use that to predict things we don't know? Well, it all comes down to one really powerful and honestly super intuitive idea.
And that big idea is basically this: birds of a feather flock together. I mean, we've all heard that saying, right? In data science, there's a fancy word for it, homophily, but it just means that things that are connected tend to be similar. Your friends probably like some of the same stuff you do. People who buy the same products probably have similar tastes. This one idea is the engine that makes this whole thing work.
All right, let's put you to the test. Look at this little network of phone users. The blue dots are iPhone users, and the green ones are Android users. Just based on that birds of a feather idea, what would you guess for those two nodes with the question marks? Chances are you immediately thought the one surrounded by green is probably an Android user, and the one next to the blue cluster is probably an iPhone user. And just like that, you intuitively performed graph classification. See, you're a natural.
So, how do we get a computer to do what you just did with your brain? Well, the first and most straightforward way to do it is with a process that honestly works a lot like a rumor spreading through a group of friends. This method's called label propagation, and it works pretty much exactly how it sounds. You start with the nodes you already know about, the iPhones and the Androids. Then they spread or propagate their label to their closest neighbors. In the next round, those newly labeled nodes do the same thing. You just keep repeating this with the colors spreading outwards until every single node has a label. In the end, a node's final identity is basically decided by a vote from its local neighborhood.
Now, label propagation is really simple. And you know what? It can get you pretty far. It's often surprisingly effective, but it has one major blind spot. It completely ignores a really crucial piece of information that we talked about just a minute ago.
And that brings us to a much smarter approach. To get past that blind spot, we need a more advanced technique, something called a graph neural network, or GNN for short. These things look way deeper than just the labels of their neighbors. So here's the key difference, and it's a big one. Label propagation only looks at the labels of its neighbors. It's basically just asking, hey neighbor, are you an iPhone or an Android user? That's it. But a GNN, it looks at all those rich attributes we talked about. It asks what's your age, what are your interests, what's your college major. It gathers up all of that juicy data from a node and its neighbors to learn a much more sophisticated picture of who that node really is.
I absolutely love this way of thinking about it. You could say label propagation is all about guilt by association.
But a GNN is more like a detective. It's out there gathering all the clues, all those attributes, from the entire neighborhood, to build a complete profile before it makes a final call. It's just smarter.
So this might all seem a little bit abstract, but here's the thing. This technology is already shaping the world all around you, probably in ways you don't even realize. So why does any of this actually matter? Well, understanding these connections powers a huge part of our digital lives. I mean, think about a system that can read social media and understand public opinion, or one that can automatically categorize billions of web pages. It's used to spot vandals on Wikipedia. And that surprisingly good movie recommendation you got last night, or the fraud alert you got from your bank, there's a very good chance a graph-based algorithm was working its magic behind the scenes.
And that really brings us to the final thought here. We are just scratching the surface of what's possible. The ability to understand networks isn't just about selling us more stuff. It could totally revolutionize drug discovery by analyzing how proteins interact, or help us build smarter cities by optimizing traffic flow in real time. So as these AI systems get better and better at seeing these hidden structures in the world's data, the real question is, what incredible new things will we be able to understand next?